Marco, welcome to the podcast.
Thank you.
I'm very excited to have you here. So before we talk about ARCA Dynamics and space traffic, what were you doing before you founded and built ARCA Dynamics? And how did the idea of space and space engineering first grab your attention?
So let's say that my background in a certain is the origin of the idea to found ARCA Dynamics. Let me better explain. I'm an aerospace engineer, graduated at the School of Aerospace in Rome. And me, Daniele and Dario are the other two co-founders, were involved together in, let's say, thesis work in robotic lab, automation and robotic lab at the university. And in a certain way, all together, we were working to the same thing, something related to image processing. My work was for autonomous landing of a rover on the moon. It was called the Google Prize. So we were involved into a sort of challenge. And me personally, I was involved into development of algorithm for image processing and autonomous definition of, let's say, hazard, in particular to avoid landing into craters. Dario was involved from his side into a project for, let's say, the optimization of algorithms for star trackers. And Daniele was involved into the creation of an autonomous algorithm for a robotic arm to let it able to detect object and to grab object. So in a certain way, we were all together involved in the same arguments. Given the fact that we were in the same lab, we have the opportunity to start discussion about the potential opportunities, industrial opportunities related to these arguments. No, but the interesting thing is that we didn't start from image processing, because another guy that was initially a co-founder, but then he decided to exit the company, was involved into an interesting project for an attitude actuator, something that is useful to modify the pointing direction of the satellite. And we were really interested in this actuator, a really innovative actuator based on a completely new approach with respect to traditional reaction wheels, because it was part of the reaction wheels. So at the beginning, when we decided to found ARCA Dynamics, it was with the scope of develop and bring to a market level this kind of actuator. So let's say that my background is strictly related to the foundation of ARCA Dynamics. But at the beginning, we were absolutely from the opposite of what we are doing now, because now we want to provide service, while at the beginning, we were thinking about the opportunity to produce hardware. So it was completely different from what we are doing now. And it's incredible now, because at the beginning, we have the expertise, we have the skills related to what we are doing now, but we decided to do something completely different. The point is that during the development of this hardware, we start to face with all the issues, all the difficulties coming from everything is related to the production of hardware. You need to have machineries, you need to have big space, you need to be compliant with the regulations. And at the end, we observed that it was really difficult to proceed in the development of this kind of hardware. And so Daniele, I have to say, Daniele had the idea to look back to our, let's say, background. And he said, why not to pivot with the initial, let's say, capabilities, that we all together were developing into the lab. When Daniele decided to look back at our background and our common experience, we identified that Dario's work was potentially an opportunity to patent. And so, starting from the decision to patent that solution, we create the core, the technological core of ARCA Dynamics. And so starting from that idea to pivot from the hardware to service solution, we had the opportunity to really develop the technology, because it's, for a startup, it's easier, no, to stay in front of the laptop and to optimize algorithms. And so this is practically the initial, my background that is strictly related to the initial idea, even if we decided at the beginning to start with something really exotic
Exactly,
with the
exactly. And
reaction, the fluid wheel. That the fluid wheel was the name of the attitude actuator. Fluid
okay.
because we were using a fluid, metal fluid, instead of solid wheels
Oh
to
wow.
perform let's say, the reaction that
And does
needed.
that work?
Let's say more or less. The problem was not. Yeah, in fact, the point is that when you are developing hardware, uh, you need to put together a lot of different, let's say, you need to solve a lot of different problems, no? Because even if from a design point of view of the wheel, we were able to optimize the shape, we were able to optimize a lot of things. The big problem was related to the electronics
Mhm.
needed to control the reaction wheel. And that there was the big issue, because me, Daniele, and Dario were not absolutely skilled about electronics. So we started some collaboration with electronics, but in the end, they were not able to solve the main problem, no,
Mhm.
related to the power consumption. So even if theoretically the reaction wheel was less power consumption with respect to the traditional one, the final solution were
Wasn't.
not so
Mhm.
optimized. So we needed to cancel that project.
And did you always see yourself building a company when you were at the lab with your now co-founders? Were you then thinking, I want to start a company, or sort of you just got together and then sort of started brainstorming as a result of seeing that you were building things that could sort of match together?
Yeah, no, I never thought me to be an entrepreneur, to found a company or something like this. But the interesting thing is that the idea was, uh, let's say, uh, let me tell you how we decided to found ARCA Dynamics. We
Okay.
were all together into a Chinese restaurant during lunch, and at a certain point I said, "So guys, we have a lot of ideas, no? Why not to try to transform it into an industrial opportunity?" And incredibly, all the other guys said that they were thinking about the same things since some months before. So the idea was inside all of us. More or less, we started to think about this opportunity at the same at the same time. So incredibly, it was living. It was starting to live inside all of us. And when I put it on the table, everyone was ready to say yes. Let's go. Let's
Wow.
found ARCA Dynamics and let's try to create. So I think no one has in mind to found a company to become an entrepreneur. And I think if we had, let's say, not a clear idea, but a rough idea about what does it mean to be an entrepreneur, I think we had closed the idea there. But because I think you need to be a bit foolish and to ignore how difficult it is to not to found, but to maintain and to let the company grow. So
Mhm.
absolutely you have to ignore how difficult it is in order to start this foolish journey. In any case, I was not imagining myself to be an entrepreneur. But
But
the idea was that in front of me, a really strong person with big capabilities, with high experience with knowledges. And so in my mind, it was a great opportunity to try to put together all these people and try to found ARCA Dynamics.
Well, so far it's gone pretty decently, to say the least, right? Because you founded the company in 2016, if I'm not wrong.
Yeah.
So it's going to make 10 years. So
Yeah,
quite nice, no? You've maintained it a long way, I have to say.
quite a long time. In fact, we are really excited to close the 10th year and to, let's say, in a certain way, to celebrate. More than the fact that we are 10 years old, what I'm really surprised about is that ARCA Dynamics in this long period improved its position in terms of not only technical industrial capabilities, but also in terms of position. ARCA Dynamics now is a bit known inside the space environment, not only in Italy. And at the beginning, if I remember that me and Daniele in particular, we tried to understand how to be an entrepreneur, no? So we started to attend to a lot of workshops. We attend to ESA programs, and me and Daniele, I remember we were sitting in front of the panelists, hearing about how to apply for proposals or how to
Mhm.
develop technology. And I thought in my mind, the point was, will we be able to, at the end, achieve this kind of result? We will be able to, let's say, create a product, no? And now that we are starting to sell the service, if I look back, to me, it seems really incredible, no? 10 years is a lot of time, but at the end, we achieved the first results in the last 2 or 3 years. So at the beginning is absolutely difficult because ARCA Dynamics was, let's say, I don't know if it's right, the spare time activity, no? Let's say,
Yeah,
more or less the hobby activities, no?
yeah.
Saturday and Sunday during holidays. So it's incredible that now is a company that is able to hire people, is able to define objectives and to achieve it. So
That's
I, I
amazing.
still I still cannot believe what
I can
Arca is
imagine.
now.
I can imagine. Now, perhaps we can move into what ARCA does now, not what ARCA started doing, but ARCA, you're monitoring space traffic and you're sort of providing a platform to manage space traffic and avoid collisions and alert of potential collisions and so on. Can you explain? Can you explain it in your own words and explain why or what is space traffic management and why is it important?
Yeah, I would say that space traffic management is the big environment. No, we are part of this environment. We are, I would say, the root part of this environment because we provide informations about orbiting objects that are fundamental information in order to perform all the other activities that bring to the capability to manage the space traffic. Manage space traffic means to be able to perform maneuvers in order to ensure that satellites do not have collisions one to the other. No? But this is the ending point. The starting point is to uh, have the better awareness about what is orbiting. What is
Mhm.
orbiting is not just related to known object, known satellite, active satellite. It is related also to unknown objects, to debris that are results of, let's say, um, injection of satellite in space, collision. Even
Mhm.
if we, fortunately, we had in the past a few number of collisions, but they created millions of objects, no debris. So we would like to start to provide more accurate, more frequent information about the orbiting objects. And this is what ARCA is doing now.
Okay.
But we are doing it from the space because, let's say, traditional approach to SST, space surveillance and tracking. The traditional approach, and since now the only one, apart from what ARCA is doing, is to try to observe and to track objects from ground using optical sensors, using radars. But it introduces a lot of delimitation. First of all, because you are fixed on ground, no? And so you can observe just what is passing over your head. And for instance, the optical sensors are sensible to the weather conditions. So if you are in a cloudy day, you cannot observe what is passing. So all the optical, even if they are really accurate in the capability to observe, but they are limited. No, radar are more flexible in terms of weather conditions, but you are limited in terms of power, for instance, and dimension of the object that you can observe. So at a certain point, given our background, technological background, we identify the potentiality coming from put the observer directly in space. And we were able to demonstrate that from space you can observe the target frequently, increasing the raw data that you need to perform, let's say, the identification of the object you're observing. Because at the end, the result of our activities and the data that we sell are related to the orbital parameters of the object observed.
Of course.
And in order to increase the quality, you need to increase the number of observations per day. And when you have your observer directly in space, you can perform maneuvers, not orbital maneuvers, just attitude maneuvers. I mean, you can change the direction, the pointing direction, in order to continuously track the object you want to observe. This increase a lot of, let's say, increase the capability to observe not only different objects at the same time from the same server, no? But you can also increase the capability to observe the smallest object. So, starting from our technology, putting our technology directly in space, you can overcome a lot of limitations that are currently associated to the traditional systems. And another important thing is that, and this is the goal of our technology, you can perform a lot of processing on board of the satellite. And you can directly download information about the object that you detected. So at the end, we can perform observations in a better way, in a shorter time, increasing the number of objects that we can observe in a single day. Why is this so important? Because at the end, if you want to have a good traffic management, you need to have information about the risk of collision, and the earlier it's possible, because the satellite needs to perform a maneuver in order to avoid collision. And an important thing about maneuvers, avoidance maneuvers, is that during that period, the satellite is not performing the service, no? And so you need to reduce the uncertainty. The 99% of collision maneuvers are performed just based on probability to have impact that at the end, let's say, analyzing the real trajectory of the object would not happen. So 99% are unuseful.
Are useless, yeah.
Maneuvers. And so 99% of the time the satellites are turned off and are not performing the service is, let's say, unuseful. And so you are losing at the end money for any reason. It's just because the information and awareness about the situation is not complete, is not fully defined. And this is why we think that space-based observation of target is really important in order to increase the capability and to reduce false positive or false maneuvers.
Okay, but so I have several questions, but the first one regarding these useless maneuvers because of false positives, as you said. But once you track or once you see an object in orbit and define its orbital parameters, you can then expand and simulate its orbit across time, right? So you know how it's going to move. So is it that important to have a continuous monitoring of some objects? Because once you see it once, you can sort of predict where it will be over the next year, right? So is it that important? Does the orbit change so much? Well, that's the first question. Then I have a few others, but
Yeah, unfortunately, objects in space are affected by perturbations, different perturbations. But at the end, the result is that the trajectory change day by day. Of course, you have a certain margin, no? So you can accept some hours of simulation, and you can say with a really small error that the satellite at a certain instant will be in a certain point. But you cannot imagine that a single observation is enough in order to simulate the position for next 10 days, months. It's
okay.
not possible because you have a lot of perturbations that modify the trajectory. Another important point is that unfortunately, satellites more and more are able to perform maneuvers. So the point is that if the other satellite is performing a maneuver and for any reason, you, the owner of the satellite, you are the owner of a satellite, and you want to ensure the best condition to your satellite, no? So you want to perform some maneuver in case you need it, but you need to know where the other satellites are. So if the other satellites are performing some maneuvers and you observe that satellite once every 2 or 3 days. You have a lack of information. You have a reduced knowledge about the position of the other satellite. So, for different reasons, you need to refresh information of the other satellite. You need to refresh orbital parameters. And please be aware about the fact that not all the objects are tracked at least once a day. You have some objects that are tracked one time per week.
Exactly.
In that case, all the other satellites are not able, or the owner or the operator of the other satellite are not able to perform simulations with that object, no? Because they are not so frequently observed and you have not updated information about the satellite. So this is why you need to perform as much observation as you can in order to have a really, really fresh and clear knowledge about the position of the other satellites.
And how is that? This is very 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 interesting because of course if you don't know where the satellites around you or the objects, because might be that satellites around you are, you risk moving your satellite around and colliding with something, right? So that's, yeah, I start to see how important it is. But how how is all this information shared? As in, like, if I were a satellite operator and I have my small satellite in orbit and I want to change its attitude or no, its orbit inclination or whatever for whatever reason, where do I go and look for potential collision risks? Is it all in your platform? Is there a large database maintained by all companies and all satellites operators, or how is that information accessible?
Yeah, you have some public catalog. Let's say 99% of satellite operators use public information, especially public catalog. The point is that those catalogs are mainly from US, so are maintained, populated, and updated thanks to the effort of the US government and US institutions. No,
Mhm.
you have some, let's say, not public catalog. For instance, for military scopes, but again, you don't have access to that kind of information. And if you are the owner of a big constellation, something like Starlink, of course you have your own catalog, because let's say that now more or less the Starlink constellation is representing with respect the LEO orbit, no? The low Earth orbit is representing the biggest number of satellites. So you have more or less 90% of satellite that is represented by, yeah. So what I'm trying to say is that if you are, as let's say, a small satellite operator, if you own just one satellite, for sure you will use public information into the public catalog, no? For instance, the NORAD catalog. If you are, let's say, a government, no? Public, an institutional entity, you have, again, the public catalog or the military catalog. If you are a private company so big to own, let's say, a big population of satellite, you have your private catalog. At the end, the point is, who is the owner of the catalog, and how is sure that in the future we will have the access to that catalog?
Exactly.
Every time I try to bring the example of the GPS, no, that is the first system in order to ground navigate, thanks to something that is free. GPS is the United US constellation that you can use, but you can use since they allow you to use it.
Yep.
At the end, it's a military infrastructure, no? So they can reduce the precision, or they can turn off the public access. So at the end, the point is, now we have public access to public catalogs, but in the future, who knows?
Exactly.
And this is another important thing that we should, let's say, approach.
Wow. Yeah. It's important to build a sovereign solution, or to ensure that you can at least survive, right? So now one more question. So do you combine ground-based observations with space observations? And also, I would think that you would need more than just one satellite in orbit, right? To make as many space-based observations as possible, you would want to have, I'm not like Starlink, but as many satellites as possible, right? Is that something that you want, right?
Yeah, absolutely. Let's say two really interesting questions. I would give you, first of all, answer to the second one. For sure, we need as much satellite as possible, because you have, even if you can maneuver the satellite, you have limitations in terms of relative orbits. And so for sure you need to increase we need to increase the number of satellites in orbit. Not only, now we are using third-party satellites, but we want to bring our technology directly on board. So we need to launch our satellites. So yes, we need to increase. We need to have, let's say, a small constellation. The other point about the fusion between space-based and ground-based, it's an interesting topic, because at the end you can merge together the advantages, no, coming from frequent observations from space and a really accurate observation from ground. So yeah, this is an interesting thing that we are absolutely studying, and we would like to implement in our service.
Okay. And just one more on this topic. If two satellites operators want to make an orbital maneuver at the same time, is there some communication between who does what and when? If, let's say, the ISS wants to raise its orbit, and Starlink and Project Kuiper and some other satellites also want to raise its orbit?
Yeah, absolutely. Given that no one is happy to perform maneuver, because you are going to use onboard propellant, and unfortunately, the amount of propellant on board since now, we are still not performing a refilling, no? But in the future, who knows?
Yep.
In any case, now the onboard propellant is a finite amount, no? So no one is happy to perform the maneuver. Usually, yes, there are interaction between two private companies or between two entities, in any case, to decide who is going to maneuver. Please consider that, again, coming back to the Starlink case, they absolutely don't want the other to maneuver. They, are not
I can imagine.
confident with the capabilities of the other operators to maneuver. So they completely charge on their side also the effort of maneuvering and avoid collisions. But it is necessary, because when you own thousands and thousands of satellites, you are the only one able to know the effect of the maneuver. Because at the end, they have a big grid of satellites. So each satellite needs to maneuver considering the position of the other satellite of the network. So if you are the owner of a single satellite and you are in the risk of a collision with a Starlink satellite, it's better that you do nothing and they perform all the activities in order to harmonize, the maneuvers of the one of all the satellites that they need to maneuver. So at the end, you have interaction if you are as small as the other operator. If you are in front of Starlink, you are requested to do nothing.
I
Just
can
don't
imagine
care about this.
exactly because they have all the information about the impact of different maneuvers, right? So it makes sense that they handle it. Okay.
Yeah.
Now moving on a bit onto like the company wise. So you are not just focused on building a software solution, right? All the space traffic management sort of platform and information analytics, so to say, but you're also aiming to put satellites yourself in orbit. That's quite a challenge, right? Because analyzing all that data is in and of itself quite a great task. But building a satellite, launching into space, and then integrating it all with your platform, it's like a whole new challenge. Why and how is that going?
Okay, so let's say that in the past, ARCA was responsible for the design, integration, and testing of a satellite. So we have, let's say, the expertise. But yeah, you're right. In any case, it's not an easy task to design, to test, and to launch a satellite. The point is that it's a big advantage with respect using third-party satellites, because with third-party satellites, we need to download images from the satellite. We task the satellite. We need to download the images, and then we perform the processing on ground. Thanks to our technology directly on board on our satellite, we will be able to perform all the processing on board. And so at the end, we are going to download a really small amount of data. And this is really, really changing the paradigm, because now everything is doing on the satellites, is just to acquire images. It's not just related to space surveillance and tracking. It's also related to Earth observations.
Mhm.
You need to download images, and this is a big effort, because satellites, even if they are designed to manage a big amount of data, but you can download it just when you are in view of a ground station.
Yeah.
And you are in view of a ground station in a limited amount of time. So you need a lot of passes over different ground stations, and it means time. If you are observing something that is static, you can accept to use hours or days to download that particular image. But for instance, if you need to observe something that is really fast changing, in our case, different objects, but also if you are observing ground, for instance, unfortunately, some, let's say, war event or other events that are evolving really fast, you should perform on board the biggest part of the processing. And this is what we want to do in order to download just what we need in order to, on ground now, perform the orbital determination of the object. This is why we want to have not only our algorithm, but we want to have our payload. And in the end, we need our satellite to onboard our payload to directly perform on board the processing of the image in order to really ensure, let's say at the end, real-time observation of the target. Because in a few minutes after the observation, we have information about the position of the satellite in the images, the target in the images. And then if we are able to download that small amount of data in a few seconds, we are really able to perform ground orbital determination in a few minutes. So it means that starting from the event of object tracking to the full knowledge about the orbit, we will have a few amount of minutes. And it's completely changing the traditional approach, no? Where you have, first of all, wait for the object passing over your head.
Of course.
It means that if you now want to have information about a particular target, you need to wait for it to be in view. And then you need to collect all the images from different, I don't want to enter into the technical issues related to the observation of the target and to the orbital determinations. From ground, you need more than one pass over the observer. So you need to wait at least to have the object over 2 or 3 ground observers.
Oh, yeah.
And this, of course, is going to increase the time you need to perform the orbital determination. We want to everything, all the, let's say, the time needed, the unuseful time, no, in order to habilitate the real-time observation.
Okay, yeah, I see the breakthrough that can provide, right? But what's then harder from the idea of ARCA Dynamics as it is now? Is it the software side, or is it building that payload and building that satellite? What's the most difficult bit?
It's an hard question. Let's say that to develop the satellites, it's not so difficult. You have a big market where you can buy components. If you have enough skills internally, you can design. It's not easy to design a satellite. The market is starting to offer satellite as a service. So you have companies that design for you the satellite starting from the requirements of your payload. So at the end, we can go to the market and ask for a satellite if we have our payload with our algorithm on board. So the most difficult topic is to be able to optimize, to develop the algorithm able to perform optical detection. But the other point is to optimize the algorithm in order to be compliant with all the constraints related to the onboard processing, because a satellite usually, even if you are not going to develop a 1-ton satellite, but this is not the case because of the cost, no? So we develop CubeSat class satellites, not a single not a few. We are developing 3 or 6 U satellites, but in any case, you have a fuel amount of power on board. So you need to be compliant with the power on board. So you need to reduce the power consumption. So you need to optimize the software in order to be, say, to run on a low consumption computational unit. So a lot of constraints. I would say that at the end, the more difficult thing is to have a payload optimized for the mission.
That seems easier than what it really is, indeed, because the constraint can become very restrictive, as you said. That's often very true.
Yeah. And then the problem is that you need to resolve a big envelope of things, because you need to think about the mission that is affecting the power board, that is affecting the platform design, that is affecting the payload capability, that is affecting the algorithm capability to perform what you want. So it's a really big environment you need to take into consideration in order to, at the end, be able to perform the mission, perform the in our case the observation. No?
Okay.
So
Okay.
a lot of variables, a lot of constraints.
Yeah, definitely, it's a complicated trade-off, right? That requires a lot of work and analysis. And
Absolutely, absolutely.
and now moving on, how how do you sell this? How is it to get your first customer? And I ask this because can this information be purely commercial? Because my feeling is that the main client or the main customer will always be an institutional one for because I think they are in most need of that information and then themselves could sort of provide it to their own to the companies in their own countries or whatever. But I don't know if my approach or hypothesis is correct. But
Absolutely correct. The point is that since now, as I said, we have public catalogs, no?
Mhm.
And so the operator approach is that it's free. Why should I pay you for your data? And they are right. It's
Up
free
to a point, of
since
course.
now. Yeah, let's see in the future. Let's see in the future. I think in the near future, let's see if it will be still free, still easy to access that kind of public data. So you're right. The main customers are institutions. Now we just closed a contract and also the provision to Visa, and we are involved into the new program USST. The USST program is a new program to develop an autonomous catalog, no, a U catalog, but also an autonomous infrastructure to collect information about satellites. So finally, fortunately, I hope not too late, Europe decided to develop its own infrastructure. And we are part of this program. We are involved into development of the first space-based sensor. It will be a 6U satellite in order to start to acquire autonomously with respect third-party providers, no? Because as I said,
Mhm.
now we are using third-party satellites. But given that it's a commercial agreement, no? You go to the providers and you pay for the data. But who can say that in the future we will be able to access that resources, no? Because everything depends on the status, no? How friendly are the interaction with other companies that are from other countries. So yeah, our main customers are institutions because private operators have access to public information. So now they are happy with that kind of, not only with the quality, but also with the frequency of that information. So now they are not in the condition to request more accurate, more frequent information. Also because, as I said, even if we have a big number of satellites now in the orbit, we are really far from a congestion condition. But when we will be in a more populated condition, no? Now we have around 70,000 satellites, considering not only LEO orbit, but also medium Earth orbit and GEO orbit. No? That is, if you consider the volume, it's a small amount of
Yeah.
satellites.
Yeah.
But given that Starlink is just at the beginning, and at the end, why not to have another big constellation for a competitor? And so if you consider that Starlink wants to have, if I well remember, 20,000
Yeah.
satellites in
The
orbit,
number
no?
is crazy. Yeah.
It's crazy, but please consider that you may have competitors, not only from the US, but also from China, no? Why
Mhm.
the Chinese government should not develop its own constellation for internet from space. So at the end, we are thinking about 100,000 satellites orbiting at that point. I think it will not be more acceptable to have information about the position of the satellite once per day or every 2 or 3 days. At that point, I think that the access to the public catalogs, no, that are free, and so when something is free, the performances are reduced usually, no. So now you can accept that kind of performances, but in the future, who knows? And so at that point, I think that also small companies, small satellite operators will try to access services like ARCA Dynamics is providing, no?
Indeed, yeah, makes sense. Makes sense. As space grows, the need for a safer space will grow with it. That's undeniable. And now you did mention one thing that was very interesting, because with the contracts that you've gained with that you've signed with ESA and the European Union, but if I'm not wrong, you're also working with the U.S. Department of Defense. Am I right?
Yeah,
And how is it that an Italian company, right, goes to work with the U.S. Department of Defense?
yeah. It was a great opportunity for Academics because the US Space Force, let's say, opened a sort of challenge, no? It's the Apollo Accelerator. And we were selected as the only company that is performing space-based SST. And so, given that we are the only one, at the end, they decided to involve also Arcadynamics. And it was a great experience, not only because we had the opportunity to understand how in the US it is working or how big is the market in the US, but because we had also the opportunity to align our procedures to all the protocols or the needs coming from that particular customer that is the US Space Force. And so we were selected, yes, and we started to provide data. But I would say that it was also the opportunity to understand how it works in the US. I think that we were involved also to understand what is really available on the market, not only to because at the end US is a closed market, and so we discovered that yes, they bought something from our ARCA Dynamics, they signed some contracts, but they want to defend the national companies, and so even if we are still involved, even if we still apply for different calls, to me it's not an easy market. Of course, we need to have a US entity. Maybe it will help in order to increase the presence of Arca Dynamics. But again, I think it's becoming more and more closed market with respect to non-US company.
Okay, okay, that's very interesting, but still, it's something to be definitely proud of.
Thank you. Thank you.
And now, before we close and finish the interview, what are the pros and cons of building the company in Italy and overall in Europe? Because of course, the US has its own set of challenges and interests, but Europe has its good and bad things. Of course, many are known to to the public. But in your experience, how would you define this?
So first of all, I would say that let's start with the cons.
Okay.
What is not positive?
Yeah.
Money. It's really difficult. Unfortunately, no, we are capital intensive at the beginning because we need to launch our satellite. It's not easy to find something that is ready to found. It's difficult to raise funds, really difficult. And at the end, the amount of money that you are able to raise is really low with respect, first of all, what you need. And if you compare to, for instance, US, but not only US, also in the other European countries, no? Italy is really unable to support in terms of founding the company. If if we think about the European Union, another really negative thing is related to the bureaucracy. Even if technically Arcadynamics is able to perform the service, now to provide the service, it's difficult to enter into public calls for provision because they introduce a lot of limitations from, for instance, the source of the data. Now we are not proprietary of the satellites. We use third-party images, but the technology is completely owned by ARCA Dynamics. We control the entire value chain because we task the satellites. We are the only one able to process the images, and we are able to perform the orbital determination. So we are completely in control of the data chain, no? But limitations from they want to control that everything is from you. But again, it's difficult to raise money in order to launch satellites. So how to develop this kind of technology in you if we don't have money to launch satellite and if we are not able to obtain public contracts for provision? Please consider that since now ARCA Dynamics is the only company in EU able to perform space-based observation. And given that, even if the USST program wants to develop the space-based observation, they decided not to give us the contract because we are not the owner of the satellite. So the point is the bureaucracy. The approach is not, it does not have a strategical view. It's just to be compliant to constraints, some requirements decided by some officer that is not a technician. And so at the end, this is the main difficulty. While from the positive point is that with a really small amount of money, we were able to develop the entire value chain, no? Starting from the negative, given that we are now performing the service, providing the service, it means that in Italy, at least in Italy, because our, all the team is composed by Italian people. In Italy, we have a lot of expertise. And please consider that we, ARCA Dynamics tradition is trying to bring guys from the university into industry, no? Given that we started from a university lab, no? This is really our approach.
That's amazing.
The main part of the company team is made by guys that performed the thesis work in ARCA Dynamics, and then they became ARCA Dynamics employees. So it means that we are not looking for people with years and years of experience from somewhere. We are just bringing into the ARCA Dynamics really young people with university experience, but it's enough. It's enough to, at the end, develop a big capability and to provide the service. This is, in my opinion, the biggest positive aspect to be in Italy, but also in Europe, because I think that more or less is something that you can find everywhere in Europe.
Definitely in Spain, I can relate to what you're saying, because I've seen similar experiences and similar sort of stories, and it's very good and also very helpful both for the graduates because they jump into the industry, and for the company because you hire talent that is fresh, new, and it's very hard working, despite perhaps not having the same technical skills as a more senior professional has.
Yeah.
But that can be learned and developed. So to me, it's not a big deal.
Yeah. I would say that they are really happy and they put a lot of energy and power. They solved a lot of problems. Sometimes I'm really, I can really not believe that they were able. I don't want to say that I don't believe in their capability, but sometimes are really difficult stuff, no? Really difficult problems. And they are able to solve it 1 week for the other, no? I come to the responsible for orbital determination. I said, oh, so what about that problem? It's solved. Solved? Yeah. Sometimes it's something that you are not able to find external companies, no, able to solve that problem. For instance, for the orbital determination, we started different interaction with companies asking for capabilities, for softwares they already developed. And at the end, the best solution was internally developed into ARCA Dynamics. And it's the solution that now is
Wow.
working for us.
Amazing. That's amazing. And now, before we fully close the interview, two more questions. One is, how does the future of ARCA Dynamics look like over the next 2, 3 medium to long term? And yeah, what else do you want to share about ARCA with the audience?
Yeah, I would say in the future, given our view about space traffic, we would like to bring on board the satellite the entire solution to the collision avoidance problem. So it's really challenging because to transfer completely on board the satellite the entire process from the detection to the collision avoidance information, it's really demanding. But I think that the only solution is to have a completely autonomous infrastructure orbiting and providing direct to the other satellite information about the risk and potentially maneuvers to be performed in order to avoid the risk. So this is technologically what I think in the, I don't know if near future or far future, but for sure what we are looking for. In terms of the company and not just technologically, I hope that ARCA will be a sort of, it will be a part of a big system, no? Where different small, medium entities are able to interact together in order to develop the real European autonomy in terms of space technology, space capabilities, because I think that Europe should really push on the needs to be more aware about the capabilities available, no?
I agree.
To really, we have the potential to be leader in the world in terms of technology, in particular in space technology. So I hope that ARCA will be part and also to promote, let's say, a sort of self-knowledge. Not, I mean, we need to be aware about the fact that we are able to perform in a more collaborative environment, not only internally in Italy but in Europe.
I completely agree with what you just said, and hope to see ARCA lead the way on that front. And last question, what do you have any piece of advice for any young professionals in the space industry, those who might be looking to start their own company, who might not be looking to start their own company but just want to jump into the industry? Any piece of advice that you would share based on your incredible experience at ARCA Dynamics?
Yeah, even if at the beginning it was completely far from I was not happy about that, but maybe I'm not so interested in my point, but to have a really strong business plan. Absolutely. Absolutely. Because it's the only way to avoid waste of money, avoid waste of time, and to be really fast to go on the market with your idea. And not to think that your idea needs to be really complicated, even if you have a simple idea, but you recognize that it's solving a big problem. Go directly on the market with a great business plan. Identify what you really need to bring that idea at the market level. It's not. It seems to be a stupid thing, but
But very
my 10
important.
years. Yeah, yeah. At the end, it's the basis for really bring the idea to a market level.
That's amazing. Well, thanks a lot, Marco. It's been a real pleasure. And
Thank
yeah,
you.
hope to hear more from ARCA very soon.
Thank you so much. Thank you for your time. Thank you for this interview.